I'm going to talk a little bit about reduction, because quite often I will say that something can be reduced to something else, but what does that mean then? Well, more precisely, I'm talking about what I call ontological reduction, which is that a concept does not refer to something that other concepts do not refer to more precisely. In other words, I'm not saying that there's something that doesn't exist, but that it can be understood more precisely in other terms. So, for example, cutlery, knives and forks and spoons, cutlery can be reduced to knives, spoons and forks. Does not mean that cutlery is something else in addition to knives, spoons and forks. On the other hand, I'm not saying that cutlery doesn't exist. I'm just saying that more precisely we can understand it as this. Heat is another example, because heat is molecular motion, and we can explain everything there is to know about heat in terms of molecular motion. So heat, it's not the case that it doesn't exist, but it's just that we can understand it more precisely. So an aim then is to reduce as much as possible in order to understand as much as possible. That does not mean that I think we should let those other concepts, that they shouldn't be used. They're very useful in the everyday life, etc. And they are very useful for seeing large connections and how things are related and so on. But sometimes if we start digging deep into the concepts, we might run into problems. And those can be solved then by translating into more precise and other concepts. So that's what we mean by the ontological reduction. So for instance, if we talk about the sun rising and setting every day, that's useful, but in reality the sun is standing still. So if we start asking detailed questions about how is the sun able to stand or to rise and to set, and how does it manage to move so quickly over the sky, etc., then we see that we need to translate it into a more coherent, more detailed and precise theory. And I'm going to say the same a lot of times about concepts like then time or probability, causality, etc. They're very useful concepts, but sometimes if we start asking detailed questions like, well, how can a non-event cause an effect? How can me not watering the flower cause the flower to die? Or how can we give a precise estimate of how probable it is that you should get this or that disease? Or how should we understand how the present moment is able to move from the past into the future? Or how is free will able to decide, etc.? There are so many questions that then cannot be answered with those concepts, and we need more precise concepts in order to answer the questions. But it still means that we need different disciplines. I'm not saying that everyone should just start using the terms that I'm using in this book. Different disciplines will let us see large connections in the world that are very useful. So it's of course much better to talk about inflation in the economy or racism in social sciences, etc., than to talk about how a lot of atoms are moving or how different values are actualized in the field. So we should definitely do that, but sometimes when those theories, the macro theories, which are very useful, when they start asking some detailed, deep questions about, well, what does that then imply about what we should think about the mind or language or truth or the connection to reality, etc., then we might have to switch over to or translate it into a larger theoretical framework with more precise concepts. So that's what I'm going to show many times in this series, that some of these other concepts and things, they run into problem when we start asking deep questions, and then we can reduce them or we can translate them into more precise concepts and solve the problems. So that's the explanation on what I meant by reduction and how I relate it, and we'll see plenty of examples later in other videos.